from the end of the last lecture. Okay, so we're talking about static features in a class, right? So you can mix static and non-static features in the class, and it's relatively common to see both static and non-static features in a class, right? You don't have to mix them, right? So it's also not uncommon to see classes that only have non-static features. We'll talk about the case where you only have static features in a little bit. Okay, so we were talking about static fields. Normally when you have a static field, I would say the most common case where you have a static field is when you have something that you want to be public and constant, right? And so in Java, if you want to make something constant, you have to be very careful about how you do it. So one of the things you do is you make it final, right? So if you have anything that's declared any variable or field that's declared final can only be assigned a value once, right? That's what it means. So here, oops, sorry, let me back up. Right, so inside the domino class, there's a field called min value. It has the value 0. Right. Normally, a public static final field is meant to be a constant value that is meaningful to whatever your class is trying to represent. Right? So we're trying to implement a domino class. The fact that there's a minimum value for each domino kind of makes sense. Right? So we can have a field called min value. So there's part of our domino class. Right? Somewhere else, right, if you try to change the value of min value, the compiler will refuse to compile your code. Right? And this includes inside the class itself. So here's domino. There's min value. Right? Here's the main method that I've stuck inside the domino class. So if I try to write something like domino.minValue equals 1, right, notice that you end up with an error. Right? It says the final field, min value, cannot be assigned. Right? It's already been assigned a value once up here. Right? So once you've assigned it a value, you can't do it again. Right? So that doesn't work. So a public static final field of primitive type, right, is always constant. Right? Once you give it a value, it can never change. Now, the problem in Java is there's also reference types. So if you have a reference type that represents something that is immutable, right, then that is also a constant. So remember in Java, strings are immutable. Right? Once you make a string, you can't change the characters of the string. So if I make a public static final string and assign it, can you not do that, please? If you have to do that, blow your nose somewhere else. It's really distracting. So here I've got a string peekaboo, and I've assigned that to x. Right? Now, you can't change the state of a string. Right? But if I try to write something like nothing to hide .x equals some other string, that doesn't work either. Right? So back into Eclipse, nothing to hide. So there's my string x. Don't do that, please. Okay, right. So if I write nothing to hide .x equals something, I see you. Right? Again, the compiler will flag that as an error. Right? The final field nothing to hide .x cannot be assigned. Right? It doesn't matter how you access this field. Right? If I just write x, same thing. Right? That x still refers to the field x up here. That field is final. I cannot give it another value. Right? So a string is immutable. It's got no methods to change its contents. Therefore, the field x isn't. Oh, sorry. Therefore, this field x in fact is in fact a constant. Right? Now the problem is if you have a reference type field, and that field happens to be mutable, right? So in other words, it has a method that can change the state of the object. Right? So final fields immutable types are not logically constant because you can change their state. Right? So here's the class really nothing to hide. It's got a public static final field that's a list, right, called empty. Right? Now the name kind of suggests that this list always should be empty. Right? So there should always be nothing in this list. Right? But if you write a main method somewhere and call a method using the name empty, it works. Right? So I can add a string to an empty list, which logically doesn't make sense. Right? So that works. So the field empty is now no longer empty. Right? And if you run that in Eclipse, right? So there's my field empty, right? It's public, static, and final. Right? So if I write empty dot add, oops, right? The compiler is perfectly happy with it, and I can even print out the string, the list now. Right? Your empty list is not empty. Right? It actually prints out this. It actually prints out the list that contains the string oops. So you have to be careful. So often, one of the big confusions with when new programmers see final is that they think it always means it's constant. Right? That's not necessarily the case. Right? If it's primitive and final, then it's constant. If it's a reference type and immutable and final, it's constant. If it's a reference type, but that reference type happens to have methods that can change the state of the object, it's not constant. Right? You cannot use this technique to create a constant object. Right? So be careful with final, right? If you remember that final means you can only give it a value once, that avoids the problems, that avoids the confusion between constantness and not. Okay, so if you want a public field in your class, right, and you want it to be constant, you can't make it mutable, right? It can't be a mutable type. You have to do something else, right? If you want a public field in your class if you want a public reference type field in your class and it is mutable, that's a little bit unusual, but you might be able to find a reason to do so. Okay, what about static methods? So static methods, those were the very first type of methods that we looked at in the course, right? Back, I guess in week 1, I told you that when you use a static method, you use the name of the class to call the method, right? Why do you use the name of the class to call the method? Because static methods are per class methods. They belong to the class. They don't belong to individual objects, right? That means the user does not need an object reference to call the method, right? So you don't make an object to call a static method. Right? You just use the class name to call the method. Right? And you'll occasionally see the term class method instead of static method. Right? Class method just means it belongs to the class. All right, so inside the Domino class, we can add a method called isValueOK, right? That tests whether or not that integer value is a possible domino value, right? So between 0 and 6. Right? Easy to implement, right? Take that value, right? Compare it to the min value and compare it to the max value, right? If it happens to lie inside that range, it's a valid value, right? If not, return false, right? Now, it doesn't make sense to make this method non-static, right? Why doesn't it make sense to make this non-static, right? Because you don't need an object, right? You never look at the faces of an object to determine whether or not that value is okay, right? In other words, this method here, right, does not depend on any of the non-static fields in the class, right? It doesn't depend on the value of side 1. It doesn't depend on the value of side 2, or whatever I called them. I don't remember what I called them, right? It only depends on min value and max value, and both of these are static. So when you see a situation like that, it makes sense to make the method static itself, right? By making it static, you no longer require the user to make an object to call the method, right? So make a method static if it does not need an object to call the method, right? So in other words, you don't need to write O dot something to call the method, right? You don't need an object when the method does not access any of the non-static fields in the class. Right? If it has to access the non-static stuff belonging to O, right? So O.some method, then the method must be non-static. Right? So inside a static method, you cannot use the keyword this, right? Why? Because when you call inside a method, the keyword this refers to the object that was used to call the method. Right? If there's no object that's needed to call a static method, then it doesn't make sense to be able to use the keyword this. Right? So you cannot use this inside of a non-static method. And a non-static method, when it's called, there's never an object used to call the method. So when you call the method, you're always using the name of the class, right? Use the class name, followed by a period, followed by the method name to call the class, right? So to call isValue OK, use the class name domino in front. Right? And again, it is legal to create an object and call the method. Right? So here I make a domino object D, and then use D to call the isValue OK method. Right? So here, it's legal, but it's considered bad form to access that method using an object. Right? If you want to call a static method, use the name of the class. Right? Eclipse will even warn you if you, most of your IDEs will warn you if you try to call a static method with an object. Okay, so now that we know what static methods and static fields, we can actually make some classes that use these things, right? So the first thing I want to talk about, or the next thing I want to talk about, is something called a utility class. And these are actually the classes that you made in the first two assignments, right? So remember what a class is in Java, right? It's just a model of a thing or concept, right? It's Java's mechanism for letting you make a new reference type. And so a class is used as a blueprint for making objects, right? So when you make an object, you can think of the class as being copied, right? So whatever non-static fields are defined by the class, the objects get copies of those fields, right? Whatever methods belong to the class, whatever non-static methods belong to the class, you can think of the objects as getting copies of those non-static methods. Right? Now, very occasionally, so this is not common, right? So very occasionally, it is useful to create a class where you're not making objects with the class, right? So this is unusual. These types of classes, they typically have no, they always have, they have no public constructors, right? Because if you have a public constructor, you're indicating that you're supposed to make objects of this type, right? Now, if you don't want to make objects using this class, right, you should have no constructors. Right? Furthermore, in these types of classes, everything is static, right? If there are any fields, they're static. If there are any methods, they are also static, right? There aren't very many of these in the Java standard library, right? And the Java standard library is very big, right? It consists of many, many classes. It has a few of these classes. These are called utility classes, right? So Java lang math is an example of one of the utility classes, right? It consists of a bunch of static methods related to mathematical functions and constants. We looked at a couple of methods in the class called arrays. Right? So arrays is a class that operates on arrays. Sorry, let's make this a little bigger. Right? So this is the documentation for the class arrays. Right? And it tells you this class contains various methods for manipulating arrays. Right? And it also contains these things called static factory methods. Right? If you scroll through and look at the methods, right? So notice the documentation starts with the method summary. Right? There's no constructors. Right? There's also no fields in this particular class, right? And if you look at the methods, right, every method is marked static, right? So there's a static method that makes a list given an array of values, right? Here's a static method that runs the binary search algorithm on an array of bytes, and so on, and so on, and so on, and so on. Right? Collections is another one of these utility classes, right? This class consists exclusively of static methods that operate on or return collections. Right? Scroll through to the documentation. Right? So there is a field. Right? Notice there's a field called empty list. Right? And it tells you it makes a immutable empty list. Right? Immutable empty map, immutable empty set. Right? Why are these immutable? Because they're public and final. Right? If they weren't immutable, then they wouldn't be constants, right? So if you want an empty list, an empty map, or an empty set, this is one way to get them. Right? Now you look at all the methods, right? Notice there's no constructors. You look at the methods, they're all marked static. So the purpose of these classes is to group together related fields and methods where you don't need an object to call the method. Java lang.math, right? That's just the mathematical constants and functions, right? You don't have to make a math object to call the cosine method, right? There's no point in making new math, right? The new math something dot object cosine, right? Just use the class to call the method. Right? Collections, those are methods that operate on Java collections. Right? Arrays, the class arrays, that's the class that operates, that has methods that operate on Java arrays. Right? So utility class is never used to make objects. Right? One of the reasons for this is because whenever you make an object, that object takes up some memory. Right? If you don't need an object to call the method, it doesn't make sense to use up memory to make the object. So when you use a utility class, it's only the class itself that occupies any memory. Right? So here I'm using math, the math class, to call cosine and sine. Right? Notice we never made a math object. In memory, all that appears is the math class itself. Right? There's the main method that's calling cosine and sine. Right? Inside the math class, you've got your fields pi and e. Right? But there's no math objects anywhere. Okay, so how do you make a utility class? Well, it's pretty easy. You just make a class and mark everything as being static. Right? So I'm going to make a utility class with one method in it and one constant. Right? So I'm going to make a class that lets you calculate E equals mc squared. If you don't know what this is just Einstein's equation for computing the amount of energy that's equivalent to some amount of mass. Right? It just consists of one equation, right? E equals mc squared. C is the speed of light, which is a physical constant. Right? Okay, so if you want to put it in a package, you make a package. Right? Give it a name. I'm going to use the name relativity. Right? Okay, so that's just the same as making any other class. Right? I'm going to add in a constant that represents the speed of light. Oops, sorry. Right? So public, static, final, double, it's primitive, so I know for sure that this thing is constant. Right? In physics, the name for the constant for the speed of light is c, so it makes sense to call it big C here. It's actually lowercase c in physics, but if you have a constant in Java, the convention is to use the uppercase, all uppercase. Right? So c equals that value there. That value is not that important for our purposes. Right? Finally, add in a method that computes E equals mc squared. Right? So make it static. Right? Give it a name, right? It needs some input, so that's just the mass, right, of whatever it is you want to calculate the, whatever you want to, that mass is, you're going to use this method to compute the energy that's equivalent to that mass, right? So that returns a double. There's your equation, mc squared, right? And then you just return that value. So it's just the same as writing any other method. Inside this method, right, you can't use the keyword this because it's static, right? I guess the only thing to note here is that that quantity there is very large, right? That's 3 billion, roughly. 3 billion, did I get that? 300 million, right? So that number there is actually quite large. Right? This is the mass in kilograms. Right? And so how do you use the class? Well, it's just a utility class. Right? So you can make a class somewhere else called 1 gram. I've got a main method. I call the method using the name of the class, right? Passing in some amount of mass. Right? So 1 gram, that's 0.001 kilograms. Right? When you run this method, it prints out that number there. Right? So that's 9 times 10 to the 13 joules, right? Which is a big number. Right? So that's a lot of energy. That's really, so if you could convert 1 gram of mass into energy, you end up with a large amount of energy. Right? And this is the foundation of nuclear power, right? And unfortunately, atomic weapons. But anyway. Okay, so that's it, right? So creating a utility class, it's very easy, right? It's even easier than making a normal class, right? Everything's static. There is one small complication, right? That's the complete, oh, sorry. Here's our complete class, right? There's just a few lines of Java. Right? Notice what's not in the class. There's no constructor. Makes sense because I don't want to make relativity objects, right? So provide no constructors. So our relativity class does not have any constructors, but you can write that. Right? So you've actually tried to type this in and you write that line of code, it will work, right? Why does it work? Remember that rule I told you a couple of weeks ago? Right? If you don't define any constructors, Java makes one for you. Right? It inserts the no argument constructor for you. Right? So in other words, the Java language is designed in such a way that it assumes the classes you're creating are meant to create objects. Right? So it silently inserts a constructor for you if you don't make one yourself. Right? So you end up with the following constructor. Right? You end up with a constructor public, no argument constructor, right? Does nothing. Right? Okay, so we don't want people to do this, right? Because there's no point in doing it, right? There's no use, there's no utility in doing this sort of thing. So you can prevent people from doing this simply by making a constructor and making it private, right? So remember what private means, right? A private field constructor or method can only be used inside of the class that it's declared in, right? In other words, anybody outside of the class can't see that feature. So stick in a private constructor of your own. It doesn't matter if this is no argument or not. You can make whatever you want, right? And have it do nothing, right? As soon as you insert even one constructor into a class, the compiler will no longer insert a no argument constructor for you. Right? By making it private, nobody outside the class can call the constructor. And so now there's no way for anybody to actually make a relativity object. Right? Notice that there's a comment in here. Right? Normally when you do this sort of thing, it's unusual, right, to make a private constructor that does nothing. Normally you should document this, that this is intentional. Right? Anybody who's making a utility class in Java or using a utility class in Java knows that this is going to happen. Right? Nope, sorry. Right? So utility classes, straightforward. Right? There's nothing mechanically difficult about making the class. It's just a regular class, everything's static. Right? The only wrinkle is don't forget to insert a private constructor so that no one else can actually make objects of your type. Okay, so that's all I want to say about utility classes, right? They're basically the simplest class that you can create in Java. So they're not that interesting. More interesting are these things called factory methods. Right? So these kinds of methods are quite common in modern Java code. Whoops, sorry. So a common use of static methods in a non-utility class, right, so in a class where you're supposed to be making objects, is to create what's called a static factory method. Right? Often you'll just see these called factory methods. Right? So a static factory method is a method that's static, right? That's why it's called static factory method. And it returns a reference to an object. Right? So in other words, it's a method that's meant to make objects. Right? That's why it's called a factory method. Right? It manufactures objects. And so the purpose of creating these factory methods is that you can make a method that behaves like a constructor, right? So it's a method, returns a reference to an object, right? What does a constructor do? Well, it initializes a new object, right? So factory methods kind of looks like a constructor, right? It's a little bit different because it's a method, so it returns a reference to an object, right? The main difference though, right? So unlike a constructor, you can give your method a name, and you can pick whatever name you want. Right? Constructor names, they're always the name of the class. Right? Now, why might you want to do this? Right? You might want to say, well, why don't I just use constructors? Okay, so back to our point2 class. Right? So remember, our point2 class has a constructor that takes in two double values, right? X and Y, sets the coordinates of the point to the value of X and the value of Y. If you've taken calculus, you probably know that there's something called the polar representation of a point, or of a circle, or something else, right, of a thing, right? So the polar representation of this point here, right, that's the distance from the origin, so that's just r, right? And then there's an angle relative to the x-axis, right? So the coordinates of this point here is just r cos theta, r sine theta, right? Which is the equation of a circle of radius r centered at the origin, right? Parameterized by theta. Right? So suppose you're implementing your point2 class and you decide that you want to add a constructor, that can make a point given its polar form, right? In other words, given r and theta, right? So I would like to insert a constructor that initializes a point given the radius given the distance relative to the origin and given the angle relative to the x-axis, right? As soon as you go to do that, you run into a problem because you've got another constructor here whose parameters are also double and double, right? Our new constructor is, the parameters are double and double, right? So these two constructors, they have the same signature, right? Their signature is 0.2 double double. You can't have two constructors with the same signature in the same class. So that second constructor causes an illegal overload, right? And so that's a problem, right? I would like to really add this constructor to the class, but I can't, right? So the solution is replace the second constructor with a static method instead, right? So the static factory method, it's a static method that returns a new object, right? I can give it a name that's not the same as the class. So that lets me get around this problem, right? I now have a method that has a different signature than that constructor that I just tried to overload. This is uncommon. You might see this called the named constructor idiom. I've never actually seen it called that, except in the reference where I got this from. Most people call these static factory methods, right? But it's called the named constructor idiom because it's a method, so it has a name, right? It makes and returns a new object. So that's sort of what a constructor does, right? A constructor initializes an object, right? New returns the object, returns the initialized object, right? But this sort of behaves like a constructor, right? So what do you do? Well, you just add in a method, give it a name. So I'm going to call it polar, right? You might call it from polar or something else, right? Add your parameters, so r and theta. Right? Now the difference here is that it returns a point, right? So you're going to say that it returns a point reference, right? And you're going to make it static, right? If you don't make it static, you need to make another point object to call the method, and I don't want to do that, right? Here I'd just like to be able to write big point 2 dot polar some r some theta, right? So how does this work? Well, you compute the coordinates of the point. That's just r times cos theta and r times sine theta, right? Now make a new object. So new, 0.2, pass in x and y and return that point, right? And now you've got a method that creates and returns a reference to a newly initialized point, right? In other words, it looks like a combination of new plus a constructor call. So that's kind of handy. There are lots of these in static factory methods, right? If you look at the, looking at the source code that I've given you for the course, and you look in the 0.2 class, you'll see that there are many static factory methods in that class, right? Don't worry about the why. If you look at the code, you'll understand. I think you'll understand why. Right? Oh, wait, sorry. We'll just skip over this for now, right? It's not that important. If you look inside the Java standard library, these are everywhere. Right? So let's go look at the string class, right? In the string class, if you look at the methods, you'll find a whole bunch of static methods called value of, right? All of these methods create a string given a primitive type, right? So value of Boolean makes a string that's true or false, depending on the value of b, right? Value of car makes a string depending on the value of c, and so on and so on and so forth, right? There's other ones as well. Where are the other ones? Oh. The method join returns a string that's made up of, you can join a bunch of other strings together. Right? Format, this is a string that returns a string that's computed based off of some formatting string. If you take CISC124 or if you learn C, you'll see a version of this method. You'll have to see and use a version of this method. Right here, it's not important, right? And if you go through the class, you'll see there's a whole bunch of other methods that are also static factory methods. Right? Remember the integer class, right? So that's the class that contains information about int values, right? It also has a bunch of methods called value of, right? Arrays has a whole bunch of methods that will compute new arrays for you, right? So copy of will copy an array for you, right? Copies in an original array, gives you back a copy of that array, right? And so on and so on and so on and so forth, right? If you spend any time looking at the classes in the standard library, you will encounter a bunch of static factory methods, right? And so that's all we need to say about static features in a class for the time being. We might come back to this when we talk about inheritance. We may not, right? Okay, anybody have any questions about static features in a class? Right, the things to remember are static features belong to the class, right? You never need an object to use a static feature. There is one thing that's not in the slides I should really talk about. Okay, so let's, I need to make a static method somewhere. Okay, let me go to the, okay, so I'm just gonna quickly create the domino class. So private int side1. I think it's value1 in the slides, but whatever. Right, this is just the value of the two sides. Right, I'm going to insert a constructor. So public, private, public, domino, side1. So, oops. So I'm going to make a constructor where we can initialize the two sides of the domino. Right, so this 1 equals side1. Remember what this means inside the constructor, right? It's a reference to the object that's being initialized, right? Now I really should in this constructor I should check that side1 and side2 if their values are okay, right? Because I don't want to make a domino whose sides are like -22 and 37, right? I can use my, oh, I don't have it here. I guess I should, I'm just going to put it in this way. So if side1 is less than min value, or side1 is greater than max value, or, side so if side 2 is out of bounds, right, I want to throw an exception. So something like that. If you wanted to, you could evaluate them individually and then give a more meaningful error message. Right here, I only know that one of them is out of bounds. You might want to indicate which one is actually out of bounds. Right? Okay, so there's my constructor, so I can now make a domino. Right? I now want to add a static method. So public static, what do I want to do? Domino copy. Okay, so I'm going to, instead of putting in a copy constructor, I'm going to put in a method that copies another domino. Right? Normally, you would put in a copy constructor, but you could choose to do it this way as well. Right? Now, so remember what I told you. So inside of a static method, you cannot use the keyword this. Right? You can't use the keyword this because this is the object that was used to call the method. Right? So in other words, if I write domino d equals new domino 1, 1. Do I have a method? Whoop. Public avoid f does nothing, right? So in other words, if I call the method f, right? The method that was, the object that was used to call f is the object d, right? Inside f, the keyword this refers to that d there, right? This is a static method, so you don't call it using an object, right? You call it using, you call it by using the name of the class. But this one does have a domino object as an argument to the method, right? So I can't use this inside this method, right? If I try to write this dot side1 equals 1, something like that, right? The compiler will flag that as an error, right? It even says can't use this in a static method, right? So you can't write that. You are, however, allowed to access the fields of other, right? Other is just a domino object. I'm inside the domino class, so I can use those fields, right? So I can use the fields of other, right? The reason I want to do this is because I want to make a new domino that's got the same sides as other. So in other words, I want to return new domino other side 1 and other side 2. Right? So that is legal. Right? If you pass the method a domino object, you can in fact access the fields of that domino object. Right? You cannot access the fields of this domino object because there is no object. Use the call the method. Right? So that's so when I say that inside of a static method there's no keyword this because there's no object that's used to call the method, right? I don't mean that object there, right? I mean there's no object used to call the method like that, right? Okay, and so that's it for static stuff in a class. And so we're now on to the next deck of slides, which I may not have handy right now. So, 14. No, that is 14. Okay. 15? No, sorry, this is a different class. Sorry? Sorry, I don't have it handy. I'm just going to jump on the on queue and grab it. So this is going to be lecture deck 15. Is that true? Yes. Oh, it's equals. Okay. All right, so equals, so remember there was a method called toString that we implemented, right? And so when we talked about toString, right, I mentioned that where this method came from was from this class called big O object, right? Now, big O object, that's the class that every other class in Java inherits from, right? So what that means in Java is any methods inside big O object, your class also gets. One of the methods inside big O object is the method called equals, right? So remember, for strings, when we're comparing strings for equality, you're supposed to use the method equals, right? If you wanted to test if two lists are equal, you use the method equals, right? Generally, if you have any reference type and you want to know is it equal to something, you use the method equals. So object defines this method, and that means your class, if you implement a class, your class gets this method called equals. Right? So our point2 class gets a method called equals, right? Even though we don't have one in it yet. Right? So if you write p equals p, that works. Right? That prints true, which is good, right? So an object p should always be equal to itself. Right? If I write something like this, p2 equals p, right? And then p2 dot equals p, that also prints true. Now remember what's going on here, right? That makes a new point object, right? Stores a reference to that object in p. That line there does not make a new point object, right? There's no constructor call here, and you're not calling a static factory method, right? Or a method that returns a point, right? So here what you're writing is p2 refers to the same object as p, right? So in other words, p and p2, you can think of them as both pointing at the same object, right? So when you write p2 equals p, that's also true, right? In fact, that's exactly the same as writing p equals p, right? Because p and p2 both refer to the same object. If I make a new point, right, so call the constructor, use new, now I really do have a new point whose coordinates are 1 and 2, right, same as p. If I use the version of equals that I get from object and compare p3 and p, that's false. Right? Now for points, that's probably not the answer that you want. Right? For points, you probably want equals to return true if the 2 points have the same coordinates. Right? So a picture of what's going on is the following. Right? There's p, there's p2. Right? Notice that p and p2, they both refer to the object at address 600. Right? P and p3, they refer to different objects, right? There's p, there's p3, right? So these 2 points, they're different objects, but they have equal states, right? Same coordinates. The method of equals that you get from big O object checks if two references refer to the same object, right? So that's the version of equals that you get if you don't redefine equals, right? Do two references refer to the same object, right? So here P and P2, yep, they refer to the same object, right? They both refer to the object address 600. But P and P3 and P2 and P3, they refer to different objects, right? So that's why that call to equals returns false, and these two return true, right? So x equals y is true if and only if x and y are references to the same object, right? Now, if you're making a class like point2, which is a value type class, right? It's a class where the objects represent values. They should probably support what's called logical equality, right? So one object is equal to another object if their states are equal, right? So 2 points are equal if their x and y coordinates are both equal, right? 2 strings are equal if they have the same length and their characters are all the same in the same order, right? That's the same is true for 2 lists, right? 2 lists are equal if they have the same number of elements and each corresponding element is equal in the 2 lists. It's different for sets. If you've done assignment 4, you should have encountered this problem, right? So in assignment 4, you're asked to implement equals such that 2 sets are equal. But the condition for 2 sets being equal are they have the same number of elements, right? And every element in set 1 is equal to an element in set 2, right? The order doesn't matter. Okay. So implementing equals, it sounds like it's something that people do all the time, right? Whenever you make a value type class, you probably want to insert an equals method. So I guess in today's world, right, this is more or less a solved issue. Back in the earlier days of Java, implementing equals was very controversial. Right? And so this is a quote from Angelica Langer. She's a Java consultant. There's 3 articles talking about implementing equals, right? So this is part 1. So implementing equals is surprisingly hard, right? This is the quote that's important down here. So look into the best Java source code or open an arbitrary Java textbook and look at what you find. Chances are good you'll find several different approaches and a variety of recommendations, right? This is no longer true. People have basically settled on how should you implement equals, right? So what I'm going to show you today is not guaranteed to produce the result you're looking for, right? Although it does give you the result that we are looking for the time being, right? So it satisfies this thing called the equals contract. The notebooks does it this way. The notebooks does it in 2 different ways. This is one of the 2 ways it does it. If you're looking at any standard Java textbook, it will do it in one of 2 different ways, right? Probably the way I'm about to show you. Actually, am I going to get to showing you? All right. So I'm going to talk about what we need to implement equals, and then I think I'll show you the implementation on Friday. All right, so if you want to know if 2 things are equal, right, then there are some requirements that we have for our equals method. Right? So number 1, an instance is always equal to itself. Right? That just means an object is equal to itself, which makes sense. Right? If you write x dot equals null, that's always false. Right? And it never throws an exception. Right? So x dot equals null, always false. You can never write null dot equals x, right? Because if you try to call a method with a null reference, that's a null pointer exception. Right? So we're only concerned with x equals null. For the purposes of this lecture, right, then instances of only the exact same type can be equal. Right? So a point2 object can be equal to a point2 object, but it can't be equal to a string, for example. Right? Later on, we'll relax this requirement. And finally, if you reach the point where these three things are satisfied, right, then you want to look at the state of the two objects, right? So two objects are equal if they have the same state, right, or equivalent state. They don't necessarily have to be exactly the same. Okay, let's do part one, and then we'll stop there, right? So part one is basically saying x equals x is always true. Makes sense, right? X equals y is true if x and y are references to the same object, right? Now we know how to compare if two things are references to the same object, right? Equals equals, if you use two references, tests are the two things, are the two references to the same object, right? So step one in every equals method is the following, right? So equals always looks like this. It's always public, it's always Boolean, its name is always equals, its input is always object, big O object, right? If you change any of that, it's no longer equals, it's something else, right? So that's always the signature of equals, right? Step one, an object is equal to itself, right? So how do you test if an object is equal to itself, right? That's the object you're comparing to, right? The object that was used to call the method is this, right? So if I want to know if these two are the same thing, you just write if this equals obj, right? And if that's the case, you can return true, right? You cannot return false, right? So if you write this not equals obj, return false, that's wrong, right? You want to test, are they equal, right? And then return true if that's the case, right? Now, you don't actually have to do this because everything else that we're going to do will eventually test for something that's equivalent. But this is very easy to test for, and so it makes running the equals method cheap if you happen to call it such that x equals x is true. Right? Okay, so that's step one. So remember, when you're implementing equals, it always starts with that line there, and that's always the first thing that you put in. Right? And we'll stop there and complete the implementation of equals in the next lecture. Right? Any questions about today's lecture? All right, so that's it for today. I'll see you on Friday morning.